All right, good afternoon, everyone. We have a little change in order here. Todd's having a little trouble connecting, so we're going to bump him to second or third whenever he's able to get in here. But welcome, everyone, to the Incident Management Breakout session of the AV Summit. My name is Mike Pack, and I will be moderating today's event. I am the Manager of Incident Management and Traffic Operations for the Pennsylvania Turnpike Commission. I'd like to thank you all for taking the time to listen to our fantastic lineup of speakers for this session. You probably heard the housekeeping items before, but I'll mention in case you just joined us. This session will be recorded and will be available to attendees later this year. You'll also see that your microphone has been automatically muted to reduce background noise. Please feel free to use the chat function on the right-hand side of your screen for general conversation and comments, but the QA section to ask actual questions about the presentations. And if you do see a question that you like, upvote the question so it raises to the top to be answered. At the end, there'll be a panel discussion following all the presentations, and I'll be pulling questions from that Q&A section I just mentioned. So any questions that are posed in chat may not be seen, will most likely be missed. So make sure you use the QA section. Our first presenter today will be Gabby Benson of Drive Engineering. Gabby?
All right. Thanks, Mike. So as Mike just mentioned, I am Gabby Benson. I have been with Drive Engineering since February 2019. I'm a traffic incident management TMC specialist for the company. Since that time that I actually been appointed with Drive Engineering, I have been working hand in hand with PennDOT's Transformational Technology Office. I've been helping them and assisting them in supporting the creation of the AV Incident Response Plan, which is what we're going to talk about a little bit today. I have 3 different areas that we're going to speak about today. Let me just try to make sure. There we go. So first up, I just want to go over a brief overview of the AVIRP itself. We're going to talk about the timeline a little bit, just talk about a little bit of the milestones we've hit with the project. Following that, we'll jump into the communication flow chart, which outlines basic communications from the incident detection portion the whole way through the post-incident activities. And then lastly, we're going to jump into the newest development in the AVIRP, which is the Pennsylvania AV Incident Response Field Guide. So jumping right in, we'll start off with the timeline here. So as you can see on your screen, we began conversations surrounding the AVIRP since 2019. So as I mentioned earlier, February 2019, PennDOT AV leadership, PennDOT's Office of Transformational Technology and the PennTime AV leadership group identified the need for an AV incident response plan. Again, that started February 2019. So from that point, summer of 2019, we developed the AVIRP framework draft. That was submitted to PennDOT, again, summer 19. Jumping into spring of 2020, we delivered the draft communication plan. Following that, winter of 2020, the Automated Vehicle Incident Response Field Guide, the mobile application, began development. Fast forward to summer 2021, the AVIRP draft has been finalized. The AV Incident Response Field Guide was out for beta testing. Now currently, fall of 2021, the AVIRP document is awaiting clearance transmittal. Additionally, the AV Incident Response Field Guide has finished the testing. And actually, most recently, they just completed their first actual training for the Field Guide mobile application with Pittsburgh Police Department, and that actually occurred last week. So upcoming, we have some efforts that are still being discussed, but training development is what we're going to be the next step for our incident response plan. Currently, the conversations and discussions are surrounding a potential e-learning platform as one of our training methods moving forward. So with all that being said, so why was the AV IRP developed? So first and foremost, PennDOT observes a lot of AV incidents, specifically the Tempe, Arizona crash in which it resulted in the death of a pedestrian. After they viewed this, they realized that, hey, we have some gaps in preparation and planning from the department. So as a result of that, the Office of Transformational Technology and the AV Leadership Group through PennTime identified the following primary goals for an AV IRP. So number one, we're going to ensure that PennDOT and all applicable stakeholders are aware of incidents involving AVs in Pennsylvania. Number two, we're going to worry about the communications. Are we going to ensure the communications are maintained to assist appropriate response and interagency coordination efforts? And third, we're going to ensure our responders are equipped with the appropriate incident response considerations so they can enhance safety by providing, which has most recently been updated to the mobile application that they can access while on scene of an incident. So today we're going to discuss the COM flow chart in addition to the Field Guide mobile application, but the framework or the AVIRP itself also provides a framework for first responders to plan and prepare for a safe and efficient management of AV incidents. It's looking into interagency coordination, those guidelines for investigation purposes, designation of responsibilities for area command within PennDOT, unified incident command, and then lastly, the PennDOT Office of Transformational Technology. From there, we're looking into preliminary and confirmed incident reporting templates, key personnel distribution list, all included in the document, as well as post-incident review templates and guidance on training and interagency exercises. So again, those are just some of the elements that we have within the document, but today we're going to look at the communication flow chart, which will be first up. As you can see on your screen, on the right-hand side, you'll see the actual full-blown communication flow chart. So basically this outlines communication avenues from the AV incident detection through post-incident activities. So first responders will be interacting with these vehicles during the active incidents, right? So while this is occurring, almost simultaneously, we're going to have some representatives from EMA and state police and DOT working together behind the scenes to communicate information between the multiple agencies and stakeholder groups. So there's going to be some various methods of notifications that will occur once the AV incident has actually been reported. These methods are broken down into verified and unverified incidents until direct communications can be made to ensure that the automated test vehicle was actually involved in the incident. So the group or persons responsible for that is going to be the PennDOT STMC. They're going to act as the information clearinghouse. As you can see on the screen there, it looks like they are the bright blue image right in the center of the screen there. So what they're going to do is they're going to effectively get notifications from potentially 7 different locations, right? So these incidents, as you can see, we have the red lines and the green lines there. The red lines are going to be the unverified incidents, whereas the green lines are going to be the verified that the AV incident was actually involved in the incident, or in the crash event, rather. So once that information comes through, once the confirmation can be made that the AV test vehicle is actually involved, PennDOT, primarily the Office of Transformational Technology and Incident Management, will then take over as far as additional upper management communications. So throughout the development, PennDOT met with various stakeholders to determine which types of notifications they would like to receive. Now, specifically, these are impacted stakeholders when I speak about that. So we're really concentrating on the areas in which we actually have testing vehicles in Pennsylvania. So we met with these stakeholders to determine which way they would like to be notified. So notifications can come through that distribution list as via email, text, or phone call. Again, this is all dependent upon those stakeholder wishes, but a lot of that stakeholder outreach was done as part of the project. So moving forward with that, we're going to go into the AV Incident Response Field Guide. This specifically is one of the areas in which we can receive notification as well, which is why I mentioned the communication flow chart. But as the second element, the AV Incident Response Field Guide was developed. And while we were working in the IRP itself, PennDOT identified the need for the first responders. So they recognize the limitations that we have of a physical field guide for all of these vehicles. You know, we're looking at an ever-changing subject matter. So as new testers come, that means additional testing vehicles would have to be added into the physical hard copy of the field guides, which, I mean, let's just be honest, that would never work for as quickly as things change around. So the thought process began circling around avenues for accessibility while actually out on the scene of the incident. So at the same time as we're having these conversations, the AV Testing Guidance Pub 950 requested that emergency service responder plans be included in the notice of testing submissions. Additionally, around the same time, we see Act 117 of 2020 passed the operations of personal delivery devices in Pennsylvania or on Pennsylvania roadways or sidewalks. So we're thinking, how can we get this information into the hands of the responders, right? So PennDOT identified the mobile application as a potential solution for the field guide. The mobile application provides an easily accessible resource to responders while also providing the ability for additional testing vehicles to be added as they receive approval through the department. So the app itself was developed with the following goals in mind. So we're ensuring that responders are aware of all appropriate incident response considerations for not only just the AVs, but now we're also including the personal delivery devices. Additionally, we're ensuring communication is maintained to assist with response and interagency coordination efforts. And lastly, we're really looking to ensure that PennDOT is fully aware of all reportable AV and personal delivery device incidents. So jumping into the app, a little bit of images here for you. So if we're looking on the left side of the screen, we're looking at the back end of the database. So this is the information that PennDOT inputs into the system once they receive these emergency response plans. The plan information is then utilized by responders in the field who may encounter the AVs during the transportation emergency or an actual crash event. So users are able to access specific information by either entering the license plate or for the AV or the personal delivery device identification number. As this information is entered, you click the Find button at the bottom of the screen, and then the app will then bring up vehicle information related to that license plate or identifier. So just to jump in, look at a little bit of a test example here. As you can see, from start to log in through your area there to input that license plate or identification number. Once the user's in the screen, they fill out all that information, click Find, boom, right-hand side of your screen pops up, and you get that vehicle information. And one of the cool things about this on the PennDOT side of things is PennDOT is actually going to be alerted anytime the app is being used. So anytime you enter a license plate or identifier, it will trigger a response into PennDOT. So not only helps the department know that there could potentially be an AV incident on the horizon that it's about to be reported, or just to make sure that users aren't randomly seeking tester information without the actual need to do so. So once that vehicle information is displayed, users can view, number one, the tester and vehicle information, which is what you see on that right image on your screen there. They can also use the one-click incident reporting function, which is at the bottom of the screen there, which will actually pull up the vehicle incident location. It will provide the GPS location of the actual incident itself, and will get relayed to PennDOT. And then lastly, the responders can access incident response information. So jumping into the incident response information that the users will actually be physically viewing while out on the scene of the incident. So we're looking at how to secure the vehicle. We're looking at location of the documentation, extrication, towing, firefighting, and post-incident considerations. So if you guys have ever actually viewed the Waymo law enforcement interaction document that they had submitted a few years ago, similar information will be found. Again, this is going to be based upon each specific vehicle that has been uploaded into the system. So whatever vehicle is related to that identifier or that license plate number, that's the information you will be able to receive. So that in itself is what the IRP mobile app is about. For anybody that's interested in jumping in and gaining access to that information, a few small steps which you are going to have to go into with your agency or your department. So you would download the application. The business partner would have to request a business partner account. Simple things such as organizational name, federal employer identification number, and just basic location information for that business. In addition to that, the business partner application will have to provide an explanation as to why they're registering to receive this required information. Once all of that information has been uploaded and submitted, PennDOT will communicate via email to let you know your status of your application. Once that application has been granted, then your first responders who are associated with your organization or agency can then create their own user profiles. Basic information would be provided in that, which would be your basic profile information, security questions, user release agreements, and also prior to submitting your profile information, you are going to have to select which type of responder you are during the registration process. Again, PennDOT's going to communicate with you via email once everything's said and done, and we'll let you know the status of that. But so there is a few different levels to actually accessing that mobile application. But once you get in there, you'll be able to jump in and see anything related to those AVs. So that's it for me. Thank you guys so much for your time, and I hope you guys have a good day.
Thank you, Gabby. Excellent presentation, and thanks again for the last second switch here. So like any good incident management coordinator, Mr. Todd Lease, we call him Dr. Incident Management, is out in the field. Todd, are you able to hear us?
Yeah, can you hear me, Mike?
A little bit.
Let me try something else.
Okay.
How about now if I speak up a little bit? Is that working?
Yeah, if you speak up, I think we can make it work.
All right.
Yep.
I have a
And
loud mouth.
Scott has Scott. Are you going to share Todd's presentation? Is that what's up now?
Yeah, I asked Scott to share my presentation so that way I won't have any issues. I have some bandwidth issues. I'm going to keep my camera off. If anybody wants to see what I look like, I'll send them a free 8x10 color glossy. So that way, yeah. Parker will send them out for me. So
Thanks, Todd. I look forward to that. I already have several of those. So.
Well, I mean, you can never have too many.
Yeah,
so,
true.
You got to ward off evil spirits this time of year too, so that helps. So,
all right, so yours, buddy.
Yep, thanks. So, I want to talk about a little bit about highway safety beyond Tim, the automated vehicles for emergency responders, and we want to set the stage for safety. So, Scott, go ahead with the next slide, please. So, a little bit about my background. I've been a volunteer firefighter since 1982 and EMT since 1985. Was a 911 operator for a number of years and a 911 instructor for a number of years. Ran with the hazmat team for Lebanon County Hazmat Team. And I started working for the Turnpike in 1999. I'm coming up to my 22nd year with the Turnpike. The past 6 years as the Traffic Incident Management Coordinator. So my job at the Turnpike is I manage the 114 fire companies, 68 ambulances, and 22 tow companies across the Turnpike system. So I interact with emergency responders, and I've been an emergency responder for a number of years. So that's why this is important for me. In addition to that role at the Turnpike, I also serve, I help lead the Penn Time, which Gabby mentioned Penn Time several times. That's our statewide traffic incident management program, www.penntime.org. And I also serve as the Assistant Director of Training for the Emergency Responder Safety Institute, respondersafety.com. So if all of you on this call remember that, respondersafety.com, and go to that, there's a very good module that we developed this year that is automated vehicle and emergency responder. So you can see some of the things that the emergency responder is thinking about when dealing with an automated vehicle. There's also some good connected vehicle training there as well. So it's a free site. You just have to register, and it's great information. So go ahead, next slide. So why is it important? One of the things that's important is the fact that we have more and more crashes every year, and responders are responding after these crashes. So those 7 photographs there are just crashes that occurred within the past year, and incidents that occurred in the last year. And on that bottom row, the 2 photos on the left were responders struck by incidents. That means they were out there helping somebody else, and they were hit. So in 2019, 2020, we had about 6.7 million police reported crashes. So in addition to crashes, we have responders out there on the side of the road helping with disabled vehicles and other items as well. So next slide. Go ahead, hit it one more time. We've also had more and more fatalities. 2020, even though we had less traffic, we had 7% more fatal crashes. So people were out there working along the roadway and involved in fatal crashes. The Turnpike this year, we have that anomaly that we have more fatal crashes this year in 2021 than we've had since 2007. And speeds are higher, and people are just losing their mind driving. And it is a major concern, a major issue. So over 38,000 fatalities in the U.S. in 2020. Next slide. So again, 6.7 million police reported crashes. Say if there's 8 responders go out there on the roadway, that's over 54 million targets. I call them targets on the roadway because when you're staying along the roadway working an incident, you feel like a target. So go ahead and click the next couple slides here. And then these are just showing you some of the incidents that occurred within the past year. So probably about 6 slides. That photo there in the lower right-hand side was where a paramedic was killed January 5th of last year on Interstate 70 in Pennsylvania. Next slide. So how do we keep people safe? One of the things, 9 out of 10 serious roadway crashes in the U.S. occur due to driver behavior. And I'm sure many of you and all of you probably on this call know that this stat's out there. Go ahead with the next slide. We talk about D drivers. So D drivers are killing us. How many of us drive drunk? Drug doesn't have to be a legal drug. Drugs could be cold and flu medicine, the COVID shot. Drowsy. Do any of you drive drowsy? Sometimes driving drowsy is worse than driving if you're intoxicated. distracted. Every one of us, could probably venture a guess that are on this this webinar today, talk on our phones in the car. Is your mind in the game when you're talking on the phone? It doesn't matter if you're hands free or using your Bluetooth. You're still distracted when you're driving down the roadway. I like to tell her that my wife likes to tell me her dream every day in real time, and I'm on the road quite a bit. So if her dream lasted 3 years, she takes 3 years to tell me her dream, and she knows my attention span is about 5 seconds. So when she gets done, she always says, "What did I just say to you?" And it's like, I don't know, because my mind's wandering. I'm thinking of other things. So we have to make sure that when we're driving, we're paying attention to other motorists out there, other responders that are out there. Deliberate, dangerous, or just plain dumb. Click next slide, Scott. How about disgruntled? Everybody always admits to being that disgruntled driver down the road, but we have those distinguished and those developing drivers, and driverless cars are out there. And that's one of the things that emergency responders are definitely afraid of. How are these cars going to recognize me as a firefighter, as an EMT, as a tow operator on the side of the road or in the road working, that are going to avoid me and not run me over and kill me? I want to go home to my family at the end of the day, and that's the one thing that we worry about most. We have Teslas that are out there. Teslas have hit, fire trucks. They've hit ambulances. They've hit police cars. And when I talk to responders and I go out and do training with responders, that's one of the biggest things they say to me is, how do I know one of these vehicles aren't going to run me over? How do I disable them if I come across there? And that's why we work with PennDOT and Gabby and Drive Engineering to develop the Pennsylvania AV Instant Response Plan. And Roxanne's going to talk about what they're doing in Maryland, very similar, I would guess. So next slide. Go ahead. Two emergency responders in the United States are struck every day. So that means their fire truck, their ambulance, their tow truck, their police vehicle are struck every day, causing property damage, injury, or death. Go ahead, next slide. A responder is struck and injured every 2 days in the United States. Next slide. And a responder is killed every 6 days in the United States. It's actually every 5.6 days in the United States. So think about that. Somebody that's out there on the roadway helping you is being killed because of distracted drivers. That's why automated vehicles hopefully will help us reduce these numbers. But for right now, this is a major concern among emergency responders. Next slide, Scott. 2019, there was 44 United States emergency responders struck and killed. That included 2 Pennsylvania emergency responders. 2020, 46 emergency responders, also including 2 Pennsylvania emergency responders. In 2021, we're already up to 51 emergency responders struck and killed, the highest number of emergency responders ever struck and killed. These are the people that are willing to give up their time, giving up their time with family, and struck and killed. And it's not just, when we talk about it, somebody said to me the one time, 46 isn't bad. Well, it's not, but after I got done throat punching him and saying, hey, even one's too many. Let's be real. Let's be smart. I don't want to hear that 51's not too bad. These are families. These are communities. These are people that are affected. Next slide. Captain Tom Royds struck on Interstate 76, the Schuylkill Expressway, on July 24th. At the time, he was the 34th emergency responder killed in the United States due to a struck by incidents this year. Again, we're up to 51. So since July, we've had that many more struck by crashes. Next slide. Paramedic Matt Smelzer killed January 5th of last year. Matt, I saw the video of him getting struck. He sees a vehicle coming up behind him. He looks back because the vehicle looks like it's going to pass him, and loses control and hits and kills him. Tyler Laudenslager, he was a tow truck operator, but also a volunteer firefighter. His baby, when he was struck and killed on July 21st of 2020, Riley, his young daughter there, was 10 months old. So she would never remember her father except through memories. Holly is his high school sweetheart. They've been married, and she's devastated. Go ahead, next slide. Earlier this month, firefighter Kevin Barry from Donaldson Fire Company was struck severely injured, and he's in rehab. And I've talked to him several times about the incident by a vehicle that failed to notice that he was in the middle of the roadway and struck him. So we'll automatically recognize him and hopefully help prevent these kind of crashes. He's very lucky. He survived. He's a survivor, but he has probably a year of rehab. He'll have to work. He'll miss work. He won't be able to do this. So I'll go ahead. Next slide. So this is what the emergency responder faces. Automated vehicles will provide significant benefits for responders and motorists alongside the roadway involved in traffic crashing, especially during the years of introduction and integration. Perception is reality. So, people think that everything's going to go nice and smooth, everything works out, but we all know with reality that we're going to have some growing pains. So that's what we're working on right now. It's what it really looks like. We're going to have some stumbles and we're going to fall, but we got to make sure that we're keeping people safe and keeping responders and motorists safe when we do this testing of the automated vehicles. Next slide. Challenges for automated vehicles. Number one thing is seeing emergency responders, knowing that how to respond to traffic incident management areas and manual traffic control. If you're out there directing traffic, what do you do? These slides here are from the responder safety automated vehicle technologies program that we have up there. So be sure to check that out. Next slide. Again, key questions for law enforcement responders and traffic and the traffic community. Go ahead. How do responders sustainable remove the vehicle? How do they stabilize that? And that's why we have that instant response plan that we've developed with PennDOT. And that's what the app that Gabby talked about. The app is very easy to use. It's very nice to work with, and it brings up, it tells you exactly what to do, where to cut, how to disable the vehicle, how to put out a fire if you have that. How do responders who might need to cut through a vehicle to remove the occupant know where to safely cut? Where's the high voltage at? And we have that problem with electric vehicles and hybrid electric vehicles. So, we're working on that. We've developed where the orange wire is and where to cut. How responders know which vehicles can be detected emergency vehicle in the first place. Are we able to see them on the roadway without hitting them? And that's a huge concern among the first responder community. Next slide. How do responders determine the ownership of such vehicles? Who owns that? If something happens, did we get to that point yet where the driver's supposed to be in control of his vehicle at all times, but is the driver going to say, well, I thought the automated vehicle was going to swerve and not cause injuries or death. So what happens there? Go ahead. Next slide. So some other challenges, for automated vehicles, how do we get these digital alerts, the responder to vehicle and responder to responder communications? How do we get that back and forth? And how do we get the responders? Are we reaching out to responders so that they understand what we're talking about when we do this? And that's the challenge for us, is a lot of the fear of the unknown for the responder. Next slide. How do we, other challenges, notification. How do we notify responders out there? Do we use transponders? Do we use standardized traffic control devices and manual traffic control devices? Or what new technologies are out there being developed? And how do we socialize that? And how do we get that out to the other responders? Go ahead, next slide. How do we communicate between human responders and driverless vehicles, or vehicles under automated control? How do we get them to move over? In Pennsylvania, the big thing is, our move over law. How do we make sure that the vehicle that are coming up to the emergency scene know enough to move over safely? Potential for unique operation characteristics. Traffic safety often depends on the ability for the driver to recognize and respond appropriately. So we want to make sure these hazards are identified and we work together to do this. Go ahead, next slide, Scott. There's my information, and I just again very quickly, please, when you're doing anything involving automated vehicles, and think about the emergency responder out in the roadway. What we developed in Pennsylvania with the Pennsylvania Emergency Response Guide is a great tool, and I'm sure what they're doing down in Maryland is also great. I'm anxious to see Roxanne's presentation, and thank you everybody for their time.
Yeah, thank you very much, Todd, for driving to a spot where we could hear you. We had some good connections there, and I do see we're starting to get some questions in. I was going to let everyone know that the first to post a question would get that 8x10 glossy that Todd mentioned, but we're just going to go ahead and send everyone that joined the session one so we can all enjoy it together. The next presenter is Roxanne Wakai, our friend from Maryland Transportation Authority's operation. She's the operations engineer down there. So to you, Roxanne.
No, once I started sharing, I couldn't find a microphone button. Okay, so thanks, Mike, for the introduction, and thank you to the PAAV Summit host for the invitation and opportunity to participate in today's incident management panel. I think I will be building off of a little bit of what Todd had said. As requested, though, I'm going to kind of use my 10 minutes to presentation time to try to foster conversation more than to convey specific information. You may be wondering why I was asked to speak on this topic. So in the conference materials and on the slide, you can see some information about me. But my first encounter with an AV device was a little over 30 years ago as a Carnegie Mellon undergraduate, tripping over the test spots, roving the sidewalks and hallways as they trained it to move around. As a civil engineering student back down on work study, I found myself tasked with building components meant to help the robotics team improve the bot's performance. Still do that now. In 2000, I joined the Maryland Transportation Authority, or MDTA, as their traffic and planning manager, and 10 years later, I joined the MDTA operations team. MDTA, like most transportation agencies, has 24/7 operations centers and safety patrols to keep our roadways flowing smoothly by providing assistance to citizens and vehicles in distress. Unlike most transportation agencies, MDTA has a dedicated police force that patrols its roadways in Maryland's larger port and airport facilities. In addition, MDTA owns a short-haul railroad. MDTA's diverse field of operations has provided me with ample opportunities to continue encountering a variety of connected and automated vehicles and devices on land, sea, and air. For example, in the early 2000s, an unidentified object found floating near a bridge pier was later determined to be a prototype unmanned submersible that had been lost by a local defense contractor when it was torn from its moorings during a storm. Today, the MDTA Police Crash Response Team uses drones to photograph and map areas of interest to speed up our ability to clear crash scenes and get traffic moving again. Maryland has a connected and automated vehicle working group, which encompasses a diverse group of partners and stakeholders. I provided website and email links on the slide for anyone interested in learning more about or collaborating with the Maryland CAV Working Group. Maryland's vision for CAVS is one of continuous collaboration with all interested partners. It's the home of institutions such as the U.S. Army Aberdeen Test Center, the Federal Law Enforcement Training Center, the National Fire Training Academy, and the Emergency Management Institute, as well as 14 of America's top 25 aerospace companies and 70 of the top 100 defense contractors. Maryland has many unique opportunities for collaboration. I'm the coordinator for the Maryland Connected and Automated Vehicles Emergency Responders subgroup activities. Sorry about that. And there are a lot of AV-related topics I could talk about and relate back to incident management, but I will only be able to highlight a few before running out of time today. Where have we been? Between 2015 and 2020, as emergency responders became more aware and involved in preparing for the advent of CAVS, I had a lot of questions about automated vehicles, some of which Todd may have brought up. Questions like, how will an AV act if it is involved in an incident or as it approaches an incident scene? Will the AV act in a lawful manner? What happens when I try to manually direct it to travel the wrong way or on a shoulder as part of a detour or to clear the incident scene? Other questions emergency responders might have asked include how do I keep the AV from restarting or moving while a stop or rescue is underway? Industry responses both then and now only create more questions. For example, in 2016, a patent was sought for teleoperation, and teleoperation could be a great idea for handling edge cases. But is an incident scene on a 6-lane freeway at rush hour really an edge case? On a congested freeway, there are over 3,000 vehicles per hour per lane passing a given point along the roadway. On really congested freeways, that number could be up to or exceeding the 3,000 vehicle mark. Let's use 2,000 vehicles per hour per lane because it's an easy number for calculation purposes. Assume that we have an incident that obstructs one direction of a 6-lane freeway. That's 6,000 impacted vehicles per hour, or 100 vehicles a minute requesting teleoperator assistance. That's one incident scene on one freeway. Now imagine multiple scenes on each freeway in each state, and the call volume is set in the hundreds of thousands. Expand the calculation to include other roadway types. And suddenly that could be 1 million vehicles stopped at incident scenes and roadways across the country, each waiting for a teleoperator to respond and provide guidance. And each of those stopped vehicles could potentially be preventing emergency responders from reaching a scene to rescue injured persons or save property. Instead of decreasing, roadway incident clearance times, traffic queues, and congestion could increase. As AVs are deployed, incident scenes and interactions with emergency responders will occur in all operational design domains and should probably not be considered an edge case. Today, there are several different efforts underway to address emergency responder needs and concerns. I'm going to hit a couple, but I probably won't hit them all. In some cases, we are revisiting old technologies. For example, using connected vehicle technology to support emergency vehicle and transit priority and preemption at signalized intersections. This has the potential to improve emergency response times or not. Emergency responders with lights and sirens on are likely to approach a signalized intersection in any lane that they can clear. They may not corresponds to the lane use of the lane they're approaching in, and the use of the SPAT mapping data may produce erroneous results, also known as a crash. A quick fix might be for the emergency response system to provide the traffic management system with planned routes for emergency response vehicles. But wait, there's roadwork on the planned route, so the emergency vehicle is not on the planned route. Incidents, events, and roadwork activities often change the reported condition of a roadway. As human drivers, we adapt the situation. We may use tools like Waze, Android Auto, or similar apps to guide planned route alterations. But when using a route planning app, what driver has to notice at one time or another that the app data was out of date or completely erroneous? Recent collaborations between transportation managers and route planning app providers have improved the speed at which emergency road closure information can be posted, but there may always be a difference between reported and actual roadway conditions. Will an AV relying on HD mapping and designated route plans be able to perceive that road conditions are other than reported and appropriately alter its route plan? Will that AV be able to avoid or turn away from hazards such as a washed out bridge, sudden sinkhole, or water or fire covered roadway? What should transportation system managers be doing to improve timeliness and accuracy of available information? Is there an acceptable fail-safe condition for the safe transportation system? Is this even a concern for today's transportation managers? After all, an autopilot for airplanes was first used over 100 years ago, and the operational design domain for an airplane's autopilot is still limited, requiring a safety operator, otherwise known as a pilot, to be on board, or a remote operator in the case of drones. On December 14, 2020, a notice of proposed amendment to the Manual Uniform Traffic Control Devices was published. The proposal included items that were presented as considerations to accommodate AVs. At first glance, the proposed revisions may not seem to be relevant to incident managers. So let's take a look at the third item, the refresh flicker rate for LEDs. I'll note that some may feel that there's no need for AVs to see a signal or a sign, as AV developers could use connected vehicle technology to maintain an awareness of changing conditions in the ODD. That's true, but then what is the AV's failsafe for those times when a connection cannot be maintained reliably, such as in a tunnel, on a long bridge, in an urban canyon, or in a remote rural area? As part of an incident management plan, LED lane use signals or signs are used to provide drivers with information on the location, the type of incident, and the recommended action that should be taken. Today, an AV's vision sensor could be perceiving some, none, or all of an LED traffic control device's message. This is a result of the power modulation units. The powers of the LED on and off too fast for a human to detect, but too slowly for a machine vision sensor not to detect. For roadways where AV traffic is permitted, the MPA proposal is that consideration be given to providing LED devices with a 200 Hertz or better refresh flicker rate. Some manufacturers may have already moved to a 200 Hertz or better setting, others have not. But at this time, there is inadequate research to confirm that the 200 Hertz setting is an optimal solution to the flicker rate. Soon, the IEEE 2020 Automotive Image Quality Working Group will be releasing a draft standard for automotive cameras. In addition, NEMA is updating Technical Specification 4 for dynamic message signs, and ATSA has formed a stakeholder group to foster collaboration and cooperation towards an LED machine vision solution that works for all traffic control devices. If the proposed 2000 Hertz or better rule or something similar is implemented, how long would it be before all of the affected devices in the field are upgraded or replaced? Some devices have a life cycle of 5 years, others 25 or 50 years. Some devices cost a few $1,000s, others may have $1 million price tag. Perhaps we could speed up the change by replacing component ports instead of the full device. However, if it takes years to accomplish an infrastructure upgrade, would the infrastructure upgrade still be needed for the AVs of that future day to operate safely? As AV development advances, infrastructure owner-operators will need to assess whether or not a potential change to roadway material design, operations, or performance to support improved AV performance is reasonably justified and feasible from a cost, benefit, and time for implementation perspective. Mike, I think I'm running out of time, so I'm going to stop.
All right, thank you very much, Roxanne. I think you did a great job of really kind of talking about some of the technical aspects of autonomous vehicles. So that was, I could see some of the questions are kind of alluding to that as well. So if all the presenters could please turn on their mics and cameras, maybe just your mic, Todd, if you're still having some connection issues, and we'll start the questions. And I see Todd and Gabby. All right. Todd, I don't want to hurt your feelings, but as soon as I mentioned that those that ask a question will get an 8x10 glossy of you, the next question was posted anonymously. I'm not going to read into that, though. But we'll go ahead and start with the questions. What's that?
That was probably Parker.
So we'll go to, before I get to the pre-canned questions, I will start with the questions that were posed in the Q&A. So from Kevin, for Todd, and others can answer as well. What is the general perception or impression that first responders have of autonomous vehicles? So Todd, when you're out and about giving your trainings, have you got any feedback from the responders when you're out talking to them?
Yeah, I teach usually at least once or twice a week, and I responders for every day, so I get to talk to them about the future and what the future holds for emergency responders, and most of the responder that I talk to, it's apprehension because they have no idea what they do or how they interact with that emergency responder. And I don't think that we do a great job of educating our responders right now on what to expect. All they see is, they don't see the positive with responders. And I try to teach that when I teach the class and say the technology to where it needs to be. It's going to be a great safety tool, but until that time, every time a Tesla hits a responder vehicle, I think the perception, oh crap, as more of these vehicles come out on the roadway, we're going to be more of a target by a vehicle that's not going to recognize us out there in the roadway. And I understand the concern, but I also think that it's actually going to help us in the future to have the automated vehicles that are going to recognize responders out there. But it's an education issue.
Yeah, exactly. And Roxanne, have you heard anything down your travels talking to responders down there in Maryland? Some of their concerns?
So there's a lot of interest. There's a lot of concern, but there's also willingness to participate in exercises to make things be better in the future. So, fire and rescue, they all want to say, can we contribute? Can we help? How do we make it better for us in the future?
Very good. Anything to add to that, Gabby?
Pretty much the same. I do see the apprehension. I was actually just speaking with somebody before I came into the office today, and they're extremely concerned about AVs coming into the public vehicle realm. The gentleman I was talking to is a truck driver, and he sees a lot of the good, the bad, the ugly when he's on the road. And one of his concerns is how are we going to navigate around major incidents and things of that nature, which is what seems to be the comments in the chat right now. So I think the more we get out in front of it, the more that we're being proactive with training and things of that nature, I think the comfortability would get there.
All right, thank you. And next question here, pretty interesting. How will autonomous vehicles know the laws of every state as they relate to first responders? So I guess one is, will they detect the first responder? And some of the concerns that all of you spoke of, but I don't know if you've heard anything from the AV companies or had this topic come up before, but I guess how will they kind of adapt laws in each state?
So I'll start with.
Yeah,
Go ahead, Todd. I'll wait.
Go ahead, Roxanne.
Okay. So we had one international group come into National Committee session and tell us that even if you just look at the manual and uniform traffic control devices for what regulatory devices they should recognize, our United States manual has over 800 pages. And in the country they worked in, their manual has 25 pages. That's a humongous difference. And they went through and counted how many states have manuals that were different from the federal manual. That was a lot. So their consideration is that every ODD, if it contains a jurisdiction, will have to have additional information on laws and rules that apply. And that might be impossible. So we'll have to figure it out over time.
Yeah, I think that's the best part about having everything in this testing phase, specifically in Pennsylvania. You know, we can address these concerns, work hand in hand with the testers to see, you know, what tweaks that can be made. And then that's really where we're at with the testing in Pennsylvania as of right now. You know, there's a lot of variables that come into play the second you cross state lines, but let's take care of the state first, and then we'll try to figure out what our neighboring states are doing after, you know.
Absolutely. I think all 50 states have Columbia have a move over law. You could make sure it's not going to follow this. Because again, Pennsylvania is a little bit different than a lot of other states. Nice, a civilian in a disabled vehicle as something you have to move over for if they're the roadway with their four ways flashing and they have monitoring device. That's something you have to move over for. A couple states that have that. So have to try to figure out how to implement that. Said too, you know, the fact that this is a major incident where we have to U-turn traffic and have.
We're starting to lose you a little bit, Todd, but I think we got most of it and got the gist. Thanks.
Yep.
I'll move on to the next question here. Will autonomous vehicles recognize a non-emergency responder directing traffic at an accident scene until responders arrive? That happens frequently when crashes happen. Anyone want to start with that one?
I personally haven't had any experience speaking with the testers regarding that type of obstruction in the roadway. However, I would imagine that we are at the forefront of that, trying to make sure, I mean, because we're even looking at fire police, you know, not always do folks actually have that responder vehicle with them, you know, especially in rural Pennsylvania where you're just going to show up in your personal vehicle. So
it's amazing, Mike, because I mean, it's a long way in the future, possibly. Right now, you just have Waymo putting out the video where they can recognize there's an officer in an intersection directing traffic. Who knows how it will grow or improve in the future.
Yeah, absolutely. Mentioned too about fire police. For people on this call, if you're not familiar with what fire police are, you know, their jurisdiction there to provide traffic control, and a lot of times the people that are working are, you know, they're 70s, and when I say 7 individual, but these are not some of the people that are out there are not the most training that the average age of a is 140 years old because they so it does concern me that you have somebody that's elderly out there directing traffic that may not want to jump out of the way or have an escape route because a car might not recognize them, and like Gabby said, it's you're not necessarily responding in an emergency vehicle. You may be responding in your private vehicle. Very similar to what the question was. How does it interact with you?
All right, thanks everyone for that. What I'm going to do is I'm going to ask one of the pre-canned questions here, unless I do see another question pop up here in the Q&A. I'll ask this, and then I'll go ahead and start to close this session. What does the landscape look like 5 to 10 years from now in regards to incident management in each one of your perspectives? I'm going to start with Roxanne.
So I'm going to say I don't have a crystal ball. It's just, who knows how much. If autopilot in airplanes 100 years later still requires a pilot, and or a drone operator, remote operator. Can we solve the question of automated driving in 5 to 10 years? Maybe, or at least some areas, some places, for some things. So I'm not sure that we have to solve the full emergency response question in that time frame, just parts of it. Gabby, you want to take up on that? I don't see
Yeah, I'll
Todd
jump
back
in.
there.
Yeah. So I think incident management right now is in a very, very good position. We're seeing a lot more states, a lot more DOTs, and just task forces being developed at this point. So I think the more that we lay that groundwork within the next 5 to 10 years, the easier it's going to be for us to be fully involved with these folks and make sure that they have as much safety considerations behind them as humanly possible. That we can train as much as anybody, but we have to have the willingness and the participation, and I think that we're finally getting that. So as we continue to test these vehicles, maybe we can have them in at the ground floor to make it a little bit easier for them to understand all of the ins and outs with the vehicles that they're going to have to approach. So I think we're in a really good spot with incident management right now. A lot more folks seem to be committed to incident management and just making sure everybody's safe when they're out there.
And I don't think Todd was able to get back on, but from the Turnpike's perspective, go ahead, Todd. I see
Are
you
you
now.
able to hear me? Yep. Hey, so for me, the landscape for emergency response to 10 years, we have less volunteer responders out there, more and more going to more and more careers. So I think it may be easier to reach them and train them and educate them on AVs as opposed to, I hate to see the volunteer role shrink. When I started as a young firefighter, we had 20 people at the fire station. Now they're lucky sometimes to get 2 people out on a call. So I think it's going to be, because we have less people to train, it may be easier to educate them and make them more of a knowledgeable responders, which may be a benefit.
Yeah, thanks, Todd. I also think kind of looking at it from the kind of more regional level for incident management, when you do start to get the queues, the back of queues, we have a responder trailing the queue to protect. We post our messages to our message signs. We have data sharing agreements with the navigation apps, with the Google, Apple, Waze. So we do our best to get the word out. But hopefully, as automation hits the streets more and more, and connected vehicles hit the streets, that we'll start to see less secondary incidents as well.
Your fingers, automated vehicles will actually follow the prescribed detour instead of going wherever.
Yeah. That's a good point. All right, so I'd like to thank all our speakers for the thoughtful discussions here and the great questions, and look out for those 8x10 glossies and that anonymous post. We'll find who you are, and you'll get an 8x10 as well. Maybe you'll get 2 of them, right, Todd?
Life size. If we track you down, you're getting a life size.
All right, so this concludes the second day of the summit. Thank you for attending this session and contributing. Please check your emails after the conference for information on PDH credits for the sessions you attended. Tomorrow we'll kick off our freight and goods day of the summit with Vivian Sun from Too Simple and Salika Telbot from Autonomous Vehicle Consulting as our plenary speakers. Their session will be followed by other breakout sessions that aim to discuss different topics related to autonomous vehicles and the movement of goods. We'll now exit this presentation mode and go back into our conference room mode, where you still have the ability to chat with other attendees if you would like. Otherwise, we hope to see you tomorrow for more great presentations. Thank you very much, everybody.